The next type is a union data type. The union data type is similar to the structured data type with a slight difference. The union data type is used to group a different number of variables and different types together using the same memory space for storing data of its member variables. Now, the difference is that the union uses the same memory space for every variable that it has. For example, here we have a student variable declared, and this union of student created. Now, just like the structure, we have character, int, and float, that is different types of data, the variables as a part of the union data type. Now, the character data type or the character variable will require only 1 byte of memory, and roll number will require 2 bytes of memory because it is an integer variable, and the float type will require 4 bytes of memory to store its data. Now, in case of the structure variables, the compiler will store 1 plus 2 plus 4, that is 7 bytes of memory for one structure variable. But in case of union, the compiler will allocate only 4 bytes of memory in total for one student variable of union type. That is because it allocates the memory required by the largest element only. These bytes are then shared by the other variables also, that is here char and int, to store their data. So this is the major difference between a structure type and a union data type. Here I have written a program that uses the union data type. I have declared the name of the union as coordinates, and I have two variables of the same type. It can be different, but here I have in for this example I needed only the int data type, so I have declared only int. I have used two coordinates, x coordinate and y coordinate variables. Now, one way of declaring the union variables is by directly writing square xy after the ending of the curly brackets and before the semicolon. Now, it can also be declared inside the main function, and that is shown over here. Use the union keyword, then the name of the union that you want to use, and then the variable name that you want to give to that union. Now, then we use this square.xy variable name further, which is like the union variable name. Now, I'm assigning the x coordinate of the union square xy with value 20. Then the value of coordinates after assigning x coordinate value 20 is printed over here. That is x and y, both the values are displayed. Then I assign the value 50 to the y coordinate, and then the value of both x and y is printed. It's a simple program. Let's run the program and see what the output is. You can see the value of x coordinate when assigned 20 is showing x is 20 and y is also 20. We had never assigned any value to the y coordinate at that point. We had only assigned the x coordinate with 20 value. But as we learned earlier, the union variable, so we have x equal to 20 and y equal to 20 because of the shared memory space concept of the union data type. Then we have y coordinate, which we assign value of 50, and then we see even the value of x coordinate changes to y. So the same applies over here. So that is all about this program. So we saw how the memory space is shared in union, while in structure it is every variable associated with the structure is given separate memory spaces.